Hey everybody, how you feeling? Good? Good? Very nice. Thank you. Okay, so I've been having a great time here. Actually just got out of the hot tub recently, really relaxed. All right. So let me tell you a little bit about what we do in Microsoft so you can understand how we approach experimentation. I'm part of the analysis and experimentation team, which is a subdivision of the artificial intelligence team at Microsoft. We have about 110 people on our team, and we facilitate experimentation across all of our quote-unquote internal customers. This is companies like Bing, Xbox, Skype, Cortana, Outlook, Office. We have about 42 data scientists. Around 75% of them have PhDs. So while I'm certainly the best dressed out of all our team members, I'm absolutely not the smartest. So some of the stuff that we may be seeing here may not be at the level of statistics that Michael so graciously just boosted me up on. But marketing versus product-based experimentation is something I've heard a lot of people talk about at this conference today and yesterday and the day before. Sometimes through presentations in a relatively subtle way, and sometimes more through actual conversations with people. We're running into issues where marketing teams who are doing experiments are starting to run into engineering teams who want to do their own experiments, and they want to do it in a pretty different way, right? Anybody experience this? Yeah, a few people. Or we have engineering teams that are doing their version of experimentation, or maybe you have a vendor like Optimizely that's starting to transition more from client-side to server-side A/B testing. Why is all this stuff happening? Well, I'm a little neurotic and kind of crazy, so I ask these types of questions. And hopefully, over the course of this presentation, you guys will get some answers to that. So, as with all mediocre presentations, we have to start with a metaphor. That was a joke. So before we really understand the differences between marketing and engineering-based experimentation, we really have to understand the differences between marketing and product, right? So I like to use this analogy of the sales life cycle of a car. Really three distinct parts that I want to focus on. Obviously, there's many more than this, but these three are engineering, sales, and product. Now, in the engineering team, these guys are primarily responsible for safety, right? Making sure that all the emissions tests are passed, the brake checks, so they can automate building the car over and over and over again in a really safe way. The sales team is focused on revenue, right? They also need to understand their market and personas. That's the market side of marketing. If a family of four walks into the car dealership, you're not going to sell them a Lamborghini. Well, maybe a certain type of family, but not most people. And so the primary metrics that you're focusing on here are conversions, revenue per visitor, stuff like that. Kind of sounds familiar, right? Lots of things that we talk about in these types of conferences. But then you have the product side because, newsflash, the customer actually doesn't stop when they buy the product. They actually have to go and use it. So they have to get in the car, experience it. How does it go around turns? How does it go over bumpy roads? So personal anecdote, my family has bought the exact same make and model of vehicle for the last decade. That's a Honda Odyssey minivan. In fact, my first car in college was also a Honda Odyssey minivan. As you can expect, that made me a chick magnet. So it's important to understand how all of these metrics apply to each one of the different groups because they're very different from each other. Safety is not the same as revenue, even though we're all part of moving towards the same goal. Okay? One of the most important things to take away from this presentation, I think, is that the product is the most important part of the business. I'm just kidding. That's actually super obvious, right? I was just channeling my inner Gary Vaynerchuk there for a second. The real important part is the closer to the product you are, the more pull you have in the business. So if you are close to the product, you have a lot of say in where those resources go. And depending on what type of company you work for, what product means in the digital context actually changes. So I define three different types of companies here. Tech first, tech second, tech third. In a tech first company, the product is the technology. So an example of this is Bing. What is the product in Bing? It's a search result, right? That's what people want. That's what they're expecting to get. That's what they want to interact with. So the product teams and the engineering teams that are responsible for making those search results more accurate and making the page load faster are some of the most important people in the business, and they get a lot of say in how experimentation resources actually get used. Now, tech-second companies, these are businesses where the end customer, the product they are consuming, is usually something physical. Maybe it's food. In the case of Booking.com, maybe it's a hotel or apartment or something like that. But still, the fundamental core business itself is still technology. But tech-third companies are where things kind of get different. This is your Sephoras, your Targets, your Subways, right? Where the actual product, the thing the end customer gets, is something physical. It's not technology. And so most of the product managers in these organizations, the products that they're managing are actually gateways. It's websites, it's mobile apps, they're things that sell the product, but they don't actually directly impact the product itself. And so in these cases, it's oftentimes the marketers who create the campaigns to sell the product that are closer to the product. And so they're the ones that get the resources for experimentation. So this has created two really distinct types of experimentation depending on what type of business you work for. And one thing that I see pretty often is sometimes you have marketers who are trying to take experimentation learnings from really big companies like Google and Microsoft and apply it to their company, but the internal structure is completely different and it doesn't work. So optimization is what I'm calling marketing-based experimentation, and validation is engineering-based. There's a few key differences that you should probably take away from this that are very important. The first is that in optimization, the feature would not exist without the experimentation tool, right? This is probably what you're most familiar with. You go out, you do research, you figure out what you want to test, all that really cool stuff. You run an experiment, and you find a winner. That winner would never have existed unless you had an experimentation program. But in validation, this is not so. In validation, what's often happening is that experimentation is simply another step in the product development lifecycle. Features are being determined ahead of time. Product managers help create those along with engineers, and once it reaches a certain stage in its life cycle, it enters experimentation. So the KPIs, it's a very subtle difference, but the KPIs are actually very different. In optimization, the KPI is improving metrics that you really care about, right? Your revenue metrics, your conversion metrics, right? Things like that. But in validation, the experimentation program actually isn't responsible for any of the improvements. That's the feature. The feature is responsible for the improvement. The program is just making sure it's safe and being able to measure. And this creates some really different internal customs. So let's talk a little bit about validation first, because that's probably the thing that you guys are most unfamiliar with, if I had to guess, and no shame in that. This is an example of an experiment that was run at Microsoft where a particular team was migrating a piece of back-end infrastructure. It's like a database or something. Now, normally, we wouldn't run a test on something like this, right? Like, why run a test on back-end infrastructure? It's not customer-facing. It shouldn't affect anybody. And yet, this particular team, because their method of validation was like Booking to test 100% of code deployments, they tested it. And what they actually found is that it was reducing some of the customer-facing metrics significantly, actually by a lot. It's really confusing. So what it turned out was happening is that there was another experiment being run by another team, and that experiment took a dependency on the infrastructure that was being migrated. So through experimentation, they were actually able to discover this. And they were able to talk to that team and say, hey guys, can you please shut this off while we run our experiment? And when that happened, as expected, the impact on the customer went to 0. So this goes back to Lucas's talk where he said, experimentation helps you find things like this. If we didn't have experimentation, well, we simply would have deployed both of these features, and the impact on all customers would have been drastic and pretty terrible. But let's talk about ROI, right? Because marketing programs really like focusing on ROI quite a lot. So what is the ROI of a validation-based experiment? Well, let's go through a couple examples. Our first example, our feature generated about $5 million, run over the course of a month on 50% traffic. Experiment number 2, we lost $5 million. Same ratios, same time period. And feature 3, nothing happened, right? That's why I use the most mediocre alphanumeric character that exists, the tilde. By the way, if you ever want to insult somebody behind their back, just call them a tilde. I do it all the time. It's great. So what is the actual ROI of this one? Depending on how you look at this, you could actually see this ROI as negative even though we had a gain. Well, why do you think that is? Well, part of it comes down to this concept of a counterfactual, which is what would have happened if we had behaved differently. Well, if we didn't have an experimentation program at all, this is a feature that was already in our backlog that we would have deployed. And if we would have just deployed this on 100% of traffic, wouldn't we have made $10 million? So the state of the world is that experimentation actually cost us money. You could also reason that this is zero as well. So what about in our experiment that generated negative $5 million? Surely it's the opposite, right? We're saving $5 million. In fact, we're saving much more than $5 million if we cut it off in time. Well, nope, the ROI on that one's zero. So how do you define ROI generally? Well, that's net profit divided by the cost of the investment. What's our net profit here? It's nothing. And what about our nothing happened, right? There was no change at all. Well, you can probably predict it at this point. It's negative 25K. What's that about? So I actually may not have told the truth entirely on our last two examples, but there's a cost to running experiments, isn't there? It's not just whether we win or lose. You're paying for your experimentation platform. You're paying for the people to design and run your experiments. And you're also paying for them to get analyzed. So what you can see by looking at this is that there's no version of this world where if you're using validation, you're making money. So why do we do this? What's the point? Well, if you want to ask that question, the real question you need to answer is, how important is insurance? I don't know about you, but I've never once paid my insurance bill and thought I was going to make money from it. But the reason that you buy insurance is to protect yourself against catastrophe. If one really bad thing happens to you, it could cost you everything. And so it's worth it to put in a little bit of money every single month to make sure if the bad stuff happens, you're covered. In fact, there's an idea by a statistician and philosopher named Nassim Taleb who wrote a book called Black Swan, all about outliers. And the concept of outliers is that you should actually prioritize making sure these don't happen over creating incremental gains. Incremental gains come and go. But one horrifically bad event can ruin everything. It can wipe it all out in a day, right? If you think this doesn't happen, last year, I don't know how many of you are familiar with this, Snapchat did a big redesign of their platform. Thought it was going to be great. Nope. Bashed in 83% of users' reviews. A huge number of customers then went to Instagram at a critical period in that company's life cycle. They had just IPO'd not too long ago. Really, really bad situation. This is the type of thing that you're trying to prevent in a validation-based environment. So now that we covered validation, let's talk a little bit about optimization. What's the good side? Well, obviously, a big part of it is the money, right? You're generating revenue if your tests are actually winning, and that's awesome. But there's a bad side here. Think back to our metaphor about the car. What is it that the engineers are responsible for? Safety checks, emissions checks, all the things that all of us take a lot of satisfaction in knowing our car is not going to blow up when we press the gas pedal tomorrow. Oftentimes, what experimentation platforms, especially client-side tools, will do is give you a way to get around all that. You don't have to go through engineering anymore. You can just do it yourself. Well, as some famous random economist said, there's no such thing as a free lunch, right? So let's talk a little bit about the good side first. This is an example of an experiment that was run by Skype where they were trying to make their contact sync proposal a little bit more engaging. This was a great thing for them to work on because they believed if more people sync their contacts, then they would have more lifetime value out of that customer, right? You're talking to your friends, you're talking to your family. And what they found after they ran this experiment was super interesting because it turned out that the translations of some of those different copies actually performed better depending on the country that the customer was in. So what really worked well in Denmark and Russia and Italy didn't work so well in Japan. And what the Skype team could do with this is then serve the appropriate translation to the appropriate country and optimize the user experience. Right? This is not possible in a validation framework. But what about some of those bad things that I mentioned? Well, as I said in not so subtle text there at the top, page speed is a monster. It'll hurt you bad if you're not thinking about it. Now, there was a company, a consultancy called Orange Theory. They actually published a blog article on CXL, so you can check it out right after this, where they measured the impact on page speed by some of the top client-side experimentation programs. And not a single one of them failed to increase latency by less than 1,000 milliseconds. Okay? Maybe that doesn't seem too much. That's a second. But let's take a hypothetical situation. And let's say that our client-side testing tool increases latency by 1,000 milliseconds on desktop, 2,000 on mobile, and 4,000 on mobile at the 90th percentile. That's like the slowest network speeds. Well, what's the impact of that? Well, if we assume that every 100 milliseconds causes a 0.5% decrease in revenue, and by the way, that's not a number I just pulled out of my butt. That's the exact number that Amazon found when they ran the same experiment. And we assume this scales linearly, which, by the way, it doesn't. That means that revenue would fall on desktop by 5%. It would fall by 10% on mobile. And it would fall by 20% on mobile at the 95th percentile before we've run any experiments. So if you're thinking about creating profit and generating revenue, you got to overcome a big old gap before that happens. And what I find is that most teams aren't even thinking about that. They're not even measuring what this gap is or whether it exists. And the next question that might come to your mind is, well, doesn't this apply to any JavaScript? Right? We add JavaScript on a page. It has to make a call out to a vendor. Well, yeah, it does. Any JavaScript snippet that you're adding to a site that's making a call somewhere else takes time. And you got to pay for that time somehow. But on to nicer, happier things. So we've talked about two types of experimentation so far, right? Marketing and product, optimization and validation. Well, there's actually a third type of experimentation, and that's research. Now, Tammy talked about this a lot, but research is something that I strongly encourage all of you to do actively. Now, in optimization, remember, we're trying to improve some of our key metrics. We want more revenue, more conversions. In validation, we're trying to prevent bad stuff from happening. In research, we don't care whether it's positive, negative, or neutral. We just want it to be interesting. Because if it's interesting, then we can do something with it, right? So for example, if I'm doing some academic research, and maybe I'm trying to figure out whether pizza causes cancer in cats, I don't know. I don't really want the cats to get cancer, unless I'm a sociopath. But I also don't want them not to get cancer. I'm just looking for something interesting. Because then other people can use that information, like veterinarians, to make better decisions about their cats' pizza-based diets or whatever. So here's an example of that we did at Bing. Looks very similar to the slowdown experiment, to the latency experiment that I just talked about a couple slides ago. So what we were able to do here is slow down the page from the server side, 250 milliseconds, and then measure how that impacted people. Now, did we expect our conversions to go up here? No, of course not, right? And we're making the experience worse. What we wanted to understand was how people reacted when the site got slow. When we were able to quantify it, then we could use that information. Here's another example. Imagine you have an e-commerce site, and that e-commerce site has a search bar. Have you ever thought about completely removing the search bar? Well, it might impact the customer experience negatively, sure. But think about something like Walmart. When you go to Walmart, do you go and ask the greeter to send you your product directly that you want? No, you browse around, right? You walk around the whole store and you kind of pick up stuff as you're walking. We don't do that on the web. What if, just putting it out there, forcing somebody to browse actually meant you made more money? Not an unbelievable concept, but it's something that should be tested, something that you can test. Some things to be aware of, though, when you're doing research-based experimentation. Now, back in 2013, Facebook put out a study where they were accused of manipulating people's emotions through an experiment. And really what they were doing was they were either showing people positive statuses, more positive statuses on their newsfeed, or they were showing people more negative statuses on their newsfeed. And what that caused was that in a small fraction of users who saw a lot more positive statuses, they started posting more positive things. And if they saw a lot more negative statuses, then they started posting more negative things. Very interesting information. Unfortunately, they didn't actually get express consent for this from their users. So there was a huge blowback. Everybody on the media was jumping in. Oh, Facebook's manipulating people's emotions. So if you want to do stuff like this, and honestly, first of all, you really need the traffic for it. But if you want to think about doing something like this, you need to think ethically, right? Think about whether or not you would like consent for engaging in an experiment like this. Would you like to be acknowledged? Think about that first before you start going down that path. So I like pretty colors. So here's the 3 types of experiments that we just talked about, and sort of the pros and the cons of each of them. Now, one thing we haven't mentioned so far is velocity, right? How fast can we get these experiments out? Well, in optimization, if you have an optimization program and it's centralized and a lot of people are coming up with ideas every single day, that can actually move pretty quickly. But that's never going to be as fast as validation-based experiment if you build that into your product development lifecycle, because then everything you ship is an experiment. The numbers are just going to increase. Return on investment, obviously, optimization is the highest. Of course, you can get return on investment in research-based as well, not so much in validation, as I showed. And you can get learnings in all 3. But typically, you get the most learnings when that's specifically what you're going after. And then finally, risk. Now, in this case, the larger the bar the risk meter has, the less risky it is. We talked about the reasons for risk in optimization-based and research-based framework, and in validation, the risk is obviously incredibly low. Okay, so what are some things that you can start doing to maybe help improve that alignment between your teams tomorrow, or today, whatever? Well, the first one is coming up with good metrics. A few metrics here that I like to use for some of my teams in the past. The first one is the conversion rate of winning experiments. These are great things to share out. How frequently are our optimization-based experiments actually winning? 10%, 35%, 45%? And is this a number that we should start increasing over time, and how can we do that? Another great one, what is our validation coverage? Meaning of all the code that gets shipped on our product, what % of it has an A/B test attached? 10%? 50? 80? So at Booking, it's 100. In some places at Microsoft, like Bing, it's also 100. Do you want to get to 100? And if you're not at 100, what sort of risk are you potentially taking on? And then finally, research conversion frequency. So this is if we're doing a research-based test, how often does that lead to an optimization-based test that's actually winning, or a new feature? This is a great way to kind of bring everything all together. One more metric that I want to mention that's not super valuable if you're an experimentation program doing this at scale, hundreds of experiments, thousands of experiments, these types of things. But that's called experiment mix. And the concept of experiment mix is that it allows us to see what percentage of our experiments are optimization-based, what percentage are validation-based, what percentage are research-based, and what do we want that number to look like in the future. This is a great alignment tool because everybody can add some input. Maybe your engineering team thinks that this number should be really, really high in terms of validation. Maybe you think that you need to invest a lot more in optimization. But it's something that you need to talk about, and hopefully you can find some agreement on. Okay, last slide. Steps to success. Now I've got an icon here, there's an arrow going up to the right, and there's columns getting bigger, so you know this is where all the awesome stuff is happening, right? Number 1. First, you need to understand what your current structure is. Are you doing more optimization? Are you doing more validation? What's happening in that other neck of the woods that maybe you're not so privy to? How much coverage is going on there? Number 2, figure out where you're lacking, right? If you're a validation team or you're an engineering team and you're just churning out these validation-based experiments, you could be making money. You're just not. A lot of times, it's pretty easy to turn a validation-based experiment into an optimization-based experiment by adding more variations. A lot of times this just doesn't happen because this isn't what the teams are concerned about. Number 3, start bridging the gap with people. Now, product teams are a great place to start here. It's really their job to be the connectors between engineering and marketing. In a lot of companies I've worked at and consulted with, that is not the case, but it should be. And if there is no product team at your business and you're a marketer, you can be the product manager, right? Take that job on yourself and connect with engineers to figure out where you should be going. Number 4, a forum for sharing results is super, super important. And when I say results, I don't really mean individual test results. I mean sort of the results of our program. How good of a job are we doing at getting alignment? Let's talk about this, and let's make sure that it's something we're focusing on moving forward. And finally, monthly meetings to review program metric goals, the ones I just talked about, in order to give insight into the overall state of experimentation at your business. Are we winning more frequently? How's our coverage? How's our mix? How are we doing moving towards these unified goals as a team? This is a great way to start getting alignment between those two opposing forces that really shouldn't be so opposing. So that's the end of my presentation. I'm wrapping up. I hope that you've had an amazing time here at CXL. We got one more speaker to go, and thank you. Thanks for letting me be here.
Thank you, Chad. We got some questions for you.
All right, let's do it.
Yeah, it's a tough question. Obviously, everybody needs to know is what do you drive now?
So I drive a 2014 Chevy Sonic because I'm environmentally conscious and/or it was cheap. Thank you.
Do validation experiments require more statistical rigor than optimization experiments based on your argument?
Actually, no. So there are types of statistical tests that you can run called non-inferiority tests that actually require about half the sample size. If you want to prove that something did not make a significant negative impact, you can run it on way, way, way less samples than you need to determine if something actually made a significant impact. There's a few papers on that. I've talked about it in the past. If you want to learn more, just come up and speak to me and I'll give you more information.
Should the same team run all 3 types of experiments? Why or why not?
I think it depends on what your team structure is. If you're really big, like Microsoft, then it wouldn't really make much sense for the engineering teams to, focus on making money, right? That goes back to that original metaphor. That's just not what they're held accountable for. That's not where they make their bonuses. They don't get a bonus based on how much money they make. So I think there needs to be some group that has insight into what everybody is doing, and usually there is, but that just needs to be surfaced a little bit more.
Okay, let's do a last question. Don't product teams try more innovative or risky things because they have the insurance of validation? Is that not a natural evolution towards optimization practices?
Yeah, I think that is definitely true. What I would say though is that if an experiment wouldn't have been something that somebody launched if they didn't have an experimentation tool, then that falls into the category of optimization, right? Remember, that was the very first category. If this is something that we wouldn't have run without an experimentation platform, it's optimization. Therefore, if it wins, it's ROI. But if it's something you would have had in the roadmap anyway, that's validation, right?
Awesome. Thanks so much for being here, Chad.
Cool. Thanks, man.